Our final example with geometric proofs, a tetrahedron is defined by the vertices OL and M and N, given vector OL equals L, OM equals M, and ON equals N. Express LM, MN, and LN in terms of LM and N. Develop the expression for the line joining the midpoints of OL to LN. Okay. So the vectors are already labelled. For A, our vector LM. So LM is here. So that can be LO plus OM. Now LO is negative L plus OM is M, which you could write as M take L. Part B, MN is going to be MO plus ON, which is equal to minus M plus N, or you could have put N minus M. And C, LN is going to be LO plus ON. And draw these on the diagram if you need to so you can see. So minus L plus N, which could also be written as N minus L. And you should know that anyway, because remember, we have already shown that AB is equal to vector B minus A, always the second minus the first. Part B, define the midpoint of OL as M1 and midpoint of NL as M2. So putting that on our diagram, let's get rid of these purple lines. Midpoint of OL, so this is OL. So this point here, we're going to say is M1. Midpoint of NL, so NL, midpoint of that, we're saying is M2. So we want an expression for the line joining M1 and M2. So M1 and 2 is going to equal, so we could go a half our LO plus ON plus a half of NL. So that equals a half of LO plus ON plus a half of NL, which equals a half of negative OL. I'm doing this a long way so you can really follow what I'm doing, plus ON plus a half of negative LN. Now note, we found LN in part C. So we've got negative a half of L plus N minus a half of N minus L. So that's negative a half L plus N minus a half N plus a half L, bringing like terms together. Negative a half L plus a half L, that goes. N take a half N is positive a half N.